What's up? I'm going to be making a Sudoku solver here. It's going to be using brute force and backtracking. So it should be pretty simple. I'm going to try to explain it right here, the logic, and then we'll get into the coding. So basically, let's say we have this grid. Let me put in some values in here. So yeah, just imagine it's all filled up. It's right there on the left. But basically, I'm going to start at the very top. So at where the 3 is, where row is 0 and column is 0, and I'm going to start going through all of them. If in the first case, for example, if we encounter a number, we have nothing we could really do there. So we'll just go to the next position, and there we'll use brute force to try plugging in all the numbers from 1 through 9. But we're going to use some backtracking. For example, if I put in 1 here, before we put in 1, we're actually going to try putting in 1 by checking. So how are we going to try that is, before we put in 1, let's see if this row and column and the 3 by 3 is valid, which is the Sudoku rules, of course. Can we put in 1 here? Let's look down the entire column and see if 1 ever exists. If it doesn't exist, then obviously it's valid so far. Same thing for this, and same thing for the 3 by 3 right here. We want to check if 1 is in here. Should be pretty simple. So let's get to the coding and then we can see how it goes. So I already have like a static grid here, so we could use this as a grid. I made the print grid function before because it's a really nice print grid function. I didn't want to worry about typing that up. So basically, I'll have a solve function that will keep track of my row and column. So when I call this solve function, it's going to be a recursive function that goes through everything. It's going to be Boolean. So for the row and column, you're going to see why I need it as a Boolean. So we're always going to start at 0, 0. Some of the important base cases I like to get out of the way are, the way we're going to traverse through this is always add 1 to the column to go to the next position. So since column is going to be increasing first, we know that it can never reach 9. So if column equals 9, then we could set the column to 0, which is going to give us the next position, and a row plus plus, because that would just give us the next position on from here to here, right? Well, you go here, then you want to set that new position here. So that kind of makes sense. It's simple, it's easy. But then if row equals 9, that means we actually went from here to here. So that means we're at the end of our board. And well, we stop here. We don't want to keep going, obviously, because we're at the end of our board. So we could actually return true right there. I'm going to say return true now. You'll see why later. But basically, that means we reached the end of the board. We filled up all the squares, and we have a valid Sudoku. What we can do now is actually print grid, so we know that's a solution. This is a Boolean function here. So what I'm going to do is, this can actually have an if statement in here, like right here, and they could actually tell you if the Sudoku has a solution or not. They'll actually check everything. So now this is where, well, we still have another easy case, which would be if we have a number. So if our grid of RC equals a number that's in there that isn't 0, so based on like this grid right here, if we have 0, so if we have a number that isn't 0, that means it's full. So we could just return go next, which is literally going to be called solve of r plus 1, well, rc plus 1, because we want to go to the next position, which would go from here to here by just adding the column forward. So now we have an empty position. Now we want to try putting in numbers from 1 through 9. So int I equals 1, I plus I is less than or equal to 9, I plus plus. And we're going to try all these values. So, but before we try them, we want to see if we could put them in or not. So we're going to see if check, and I'm going to make the function now. So if our check will equal true, then that means we could set the value to what it is and then keep solving. So that's gonna make us say grid of RC equals I. We set it to 1 and now we solve at R comma C plus 1. But the thing is, if we don't solve it, like if we do solve it, there's a lot of backtracking that's going to happen, so it gets a little complicated. So basically, so if it's solved, that means we reach the solution at the end somewhere. So that means we could return true. So basically keep returning true and keep saying it's been solved. But if it's not solved, then this isn't really needed, but we could set it back to 0 before we set it to a value. So we're going to call this check function. So this check function is going to be used. I'll go over this again. Let's get over the check function. So our check, we're going to pass in the row and column because that's what we want to check. But not only that, we also want to pass in the number we want to try putting in the row and column. So we're going to pass in I. So let's make a check here. Static Boolean check. Passing in the row and the number you want to put in. I'm going to call it none because I don't want to use I since I'll use for loops in there and stuff. None in this case actually, because I'm going to try minimizing this and I'm actually going to return the check of the row, the column, and the grid. So check row, I'm going to make Boolean functions for all these because I just do not want to make a mess in my check function. So this really minimizes like a lot of things. So if all these equal true, then it's true. And if not, then obviously there's one problem and that solution doesn't work. Check row, check column, and check, I don't know what to call it. Check square. It's like the little 3x3 you have there. So when we check row, we don't really care about the columns. Like we don't really care about the column. So all we have to do is really pass it in the row and the number we're checking for. So for this one, the column and the number we're checking for. This one checks square. I'm going to do some cool math for this one. So then I could just pass it. I'm going to need to pass it RNC and the number. So let's type up check row real quick. Boolean check row given int r int number. So I want to check row. So basically these are our rows, right? 0, 1, 2, 3, 4, and so on. Columns 0. I should get rid of some of this, but whatever. Yeah, so 0, 1, 2, 3, so on. 0, 1, 2, 3, whatever. So these are our columns up here and our rows. So if we pass in the row, right, is the row we're at, and we want to check that row. So what we're actually doing is checking, like, for example, this entire row. So that means our R is going to stay the same, and our column is going to have to change with a for loop going through all this. So at position 0 all the way to the end of the board, and if grid of R of I equals the number, that means if we encounter that number, then there's a problem, we could return false. And then if there's no problem, you could return true. And basically this is actually going to use the same logic for column. If you understand it so far, it's like pretty simple and it makes sense why we're going to need this for column. Because now we pass it to column, and we want to go from, so now what that does is we pass it to column. For example, this column here, let's say we were passing in 3, we want to check all of this and see if the number we're passing it in is ever found. So the column stays the same, and we go from 0 to 9 on the rows, and we see if that number is ever there. We return false, and return true if it's not there. Then the check square is probably one of like the harder ones. It's kind of annoying, but it's going to make a lot of sense, and then it's actually really easy, but it's pretty cool. So we pass in all this. So basically the problem is, you could try figuring this out. You're going to be given just the row and the column, right? For example, I'm going to say 2, 3. So 0, 1, 2, 3, 0, 1, 2, 3. So 2 would be at row 2, 1, 2, 0, 1, well, row 2, but column 3, right here, right? This is what we're, so we want to check this grid, right? We want to see if a value exists in this grid. So all the grids are set up like this, right? Because it's a Sudoku board. So we want to see, how do we check this grid? Well, it's like pretty weird, right? Like, how are you gonna get this value and check this whole grid? But basically what you're gonna do is, I found this out, there's a lot of different ways to do this. Some people do it with modules, modulo, whatever. I actually just divide using integer division. So basically, given my row and column, actually, I divide it by 3, and then I multiply it by 3. And same thing for column. And what that does, if you do the math, you can check it with all of them, it'll always land you in this box exactly for all these values, because what it does is it divides it by 3. So for example, 2 divided by 3 equals 0, multiplied by 3 it ends up in 0. For this one, now we have 3 divided by 3, it's 1 times 3, so now our column ends up in position 3 because it's 1 times 3. It's like pretty cool. Just like try this out, this formula, whatever, for both columns as well, and it makes a lot of sense, and it was pretty cool. A lot of people do it with modular, like division, whatever, and it's a lot easier maybe with that, but I thought this solution was pretty cool and I figured it out. So we want to get that int, so like top R is like the top of the row, and we want to get equals R times 3 divided 3. We want to do the same thing for our column. So now that we're at this top, we know we could do the whole double loop to go through all the squares. So for n I equals 0, I less than 3, plus plus. So if, and then you'll see it makes sense now. If grid of top row plus I, and top column plus I equals num, return false. So what I do here is pretty cool. So basically we're gonna have 0, 0, so it checks of this, it's gonna check that 0 position. I is gonna go, well, J is gonna go +1 first, so that adds 1 to the column, so then it goes here, and so on, and it basically does that whole double loop through all these, starting with this. So it's pretty cool, and then obviously your top R, top C are gonna be all these top rows, top column values. So that's basically our whole check. I think I'm basically done. Hopefully I don't run into any errors and this runs first try. So yeah. So we have check square, check column, check row. So, and a total check because I wanted to put it in its own function. So let's go back to our solve. I kind of skipped over it because now I really want to get into detail that we have the check out of the way. So we understand this, and we understand if there's a number, we go next. So now we have an empty spot. We're going to loop 1 through 9, and we're going to try plugging all those in. But we don't try plugging them in first. First we check if it's possible to plug in. If it is possible to plug in, let's put it in. And now let's solve that new grid that we have at the next position. So if that solve ever does end up getting to the end, we could return true. The only way for solve to return true is by getting to the end. If you see here, there's going to be our only true function. Our only true return. So basically, if none of the values ever work, let's think. So if none of the values ever work, our for loop should be done here. We actually just return false. But if you have a valid board, this call should never be called because you're going to try plugging in 1. Oh, well, it will obviously happen like in the future though. And then that basically means like you're at the final square, and let's say you're at like the final square, one of these squares, and you try plugging in 1 through 9, and you get all these errors and all these like checks are equaling to false and whatever. Then we make sure that we keep that grid of RC equal to 0 before we go next, and then we return false when none of the values actually work. That should be it. So yeah, my main. So yeah, so if I run it, I should get something. Hopefully not an error. Let's see. And I got a bunch of errors. Out of bounds. So I probably have that somewhere. Okay. So grid top R. Okay. Yeah, there we go. That should be it. And let's see if more errors come up. So top row is our I, J. So row, bro. Row divided 3 times 3. Okay. Yeah. And there we go. Yeah. That's the valid Sudoku. So basically, yeah, you could check it. Everything looks good. You could try this with a bunch of other Sudokus. This was one way that I learned from a professor of mine. I thought it was amazing. Very simple backtracking. Amazing way to learn it as well. A little bit of literally brute force and simple backtracking. Yeah. Thank you.